Good morning, good afternoon, good evening, everybody. Welcome to this yet again another video on pre-calculus. This time, our lesson of the day is devoted to one topic, simplifying rational expressions. Without any further ado, vamos! What's going on in this section? What does it mean to simplify rational equations? Well, there are a certain number of active principles we need to take a look at. So active principles. These are going to be the algebraic rules we're going to be using in this section. So the first one, if I have A over B, that multiplies C over D. So two fractions multiplying each other. How does this behave? Top with top, bottom with bottom. So that's AC over B times D. Good. Here's another one. Suppose we have, this time instead of a multiplication, let's consider a division. So A over B divided by C over D. This is A over B multiplied by, what happens when I change a division to a times? You know that? We flip the following fraction. So instead of divided by C over D, it's going to be times D over C. Final result, AD over BC. Good. Let's continue our little investigations of basic algebra rules by this time putting a plus or a minus in between the fractions. So plus or minus C over D. Now a plus or a minus between fractions means we need to take what? A common, you know this, denominator, right? Now, a common denominator is something simple. All you got to do is multiply the two denominators. That's like first step. Multiply the denominators B and D. So B, D in the bottom. And then we crisscross. A times D. And then B times C. And whatever sign in between is the sign that we keep. Yes? All right, here's one last that will be useful. If you have P times Q over P, notice that this is a multiplication here. Are we or are we not allowed to cancel the P's? And because it's a times, the answer is yes. So this is actually equal to Q. These are the principles we're going to put to good use in the following examples. Good. All right, so example one. Let's start slow, 2 stars. So example 1, 2 stars. We will try to simplify completely the following expressions. This reads, in the numerator, 2x plus 1 in a bracket times x minus 3 in a bracket as well over 2x plus 1 times x plus 2 all in a bracket. So we'd like to simplify this, and we will notice to begin with that there are multiplication signs here and there, right? So what does that allow me to do, those multiplication signs? Well, question, can I cancel 2x plus 1 with 2x plus 1 since they seem to be exactly the same? And the answer is yes, because because those guys, 2x plus 1s, are multiplied by something that follows. The top one is multiplied by x minus 3, the bottom one is multiplied by x plus 2, so this is actually equal to this. Good. Is that our final answer? Should I box this and consider the problem to be complete? The answer is yes, because I cannot cancel this x and this x. No way. You know why? Because this x is followed by a plus sign, while the bottom x is followed by a plus sign as well. If something is multiplied by something else, we can cancel. If it's added, subtracted, no, we can't. Okay. Now, a little remark that some of you will find useful. Here, if we expand, and I know many of us on problems like this have this reflex of expanding the brackets up and down. If we expand both top and bottom, what are we going to get if we expand both numerator and denominator? Well, it's pretty simple really. So 2x plus 1 x minus 3 over 2x plus 1 x plus 2 actually becomes, let us FOIL, right? So 2x squared minus 6x plus x minus 3. That's what I get for the numerator. In the bottom, 2x squared plus 4x plus x plus 2, which actually gives me, if I collect my like terms, I will get 2x squared minus 5x minus 3 over 2x squared plus 5x plus 2. Now, this is not wrong, but it is not simplified. It actually goes against what we wanted to do. Remember, we want to simplify completely. If we have that, can I cancel the x squares up and down? No, because the x squares are followed by either a plus or a minus. They're not available for cancellation. Can I cancel the 5 and the 5? No, for the same reason. The x and the x? No, for the same reason. So this is not algebraically wrong, it's just not simplified. And it goes against what we wanted to do, which was to simplify. So let's not do that. Let us try to see if we can find a way to factor top and bottom as opposed to expand horizontally. All right, let's take a look at another example. All right, what do we have here? I have here something called, alors exemple 2, let us hike this up to 2.5 stars. Simplify completely, this is 2x3 plus x squared over 2x3, no, I'm wrong, 2x2, sorry, 2x2 minus 3x minus 2. All that jazz is actually multiplied by x squared minus 4 over x3 plus 8. All right, so clearly I'm not going to start doing crazy stuff like canceling x2 and x3 here, or the 4 and the 8. I know this is illegal. What I need to do here is put to use my principles of factoring that we have seen in previous videos. So what's that equal to? What could we do to this guy 2x3 plus x squared? Can we factor out something? The answer is most certainly we can factor out an x squared. And I'll be left with what? 2x plus 1. Agreed? All over. Oh, a trinomial. A trinomial can be factored using the ever so popular product sum. Let's go aside for 1 second. We are now looking for two numbers whose product is 2 times minus 2, so minus 4, and whose sum is minus 3. What are such numbers? Product of minus 4, sum of minus 3. The numbers are minus 4 and 1. Would you agree? If you do, then we can actually replace the middle term minus 3x with minus 4x plus 1x minus 2. And in a minute, we'll double factor and complete this factoring. This is multiplied by, take a look at this, x squared minus 4. What do you recognize here? If you said difference of squares, you're right on. So that's x minus 2 and x plus 2. We got to be good with factoring if we're going to be successful in this chapter. Divided by, look at the bottom, x3 plus 8. Oh, x3 plus 8. That's a sum of cubes. Oh, sum of cubes. I remember this. So this is going to be x all cube plus 2 all cube. So my a is x, my b is 2. Putting that into the formula that we know is going to give me x plus 2 times x squared plus 2x plus 2 squared, which will be 4, clearly. Okay, we still have to double factor this guy down here. So that's x squared 2x plus 1. Double factor this, so common between 2x squared and minus 4x is 2x. And you get basically x minus 2. Plus, what is common to x minus 2? Not much. Let's have a 1. And this will be x minus 2. All this times the rest. That doesn't change really. We just recopy. X plus 2. X squared plus 2x plus 4. Lovely. So, where are we with this 2.5 star problem? X squared 2x plus 1 all over. Oh, I know double factoring is successful if the amount in the bracket is the same. So we refactor out the x minus 2 and we get 2x plus 1 times x minus 2, x plus 2, x plus 2, and x squared plus 2x plus 4. Time to see if we can cancel anything. Do you see up and down cancellations in this? Yes, there are plenty. Here's one. 2x plus 1, 2x plus 1. Here's another. X minus 2, x minus 2. Why can I cancel those? Because of the multiplication here. What else? X plus 2 and x plus 2. Good. I believe we have reached the limit point of this problem. Only thing left in the numerator is x squared. And then in the numerator, only the trinomial remains, which comes from a sum of cubes, right? Which comes from a sum of cubes. We know that these trinomials that come from a sum of cubes can never be refactored. So I'm not even going to try. Plus 2x plus 4. And that's my final answer. Let's not go crazy by doing stuff like canceling x squared and x squared. I can't. The top x squared is available for simplification. The bottom is not because it is followed by a plus sign. Good. Excellent. So moving on to the next example 3. Let's see if we can hike up the stakes to 3 stars this time. All right, example 3. 3 stars. What do we have here? Again, simplify completely. X squared minus x minus 2 over x cubed minus 2x squared plus x minus 2. So 4 terms in the bottom, 3 in the top. And then here's the difference between example 2 and example 3. This is a sum. Plus x squared plus 1 over x cubed plus x. All right. So here we are adding two fractions, right? This is like we saw at the beginning of the video in one of the active principles, the third one actually, a over b plus c over d. I need a common denominator, which should be, technically speaking, this guy times that guy. But before I go into this, I find my denominators relatively complicated. Let's see if we can possibly simplify them before we take the common denominator. So what's this equal to? The top is a trinomial, right? So I will assume that we are starting to know how to do this fairly well, and I will go quickly over the factoring of this trinomial. The product sum, I'm looking for two numbers that are actually -2 and a sum of -1. So I'm going to get the two numbers that are -2 and 1, and it's going to turn out to be this, x minus 2, x plus 1. I did go quickly over this, so you might want to pause the video if you're at home and do this slowly by yourself to actually convince yourself that indeed this trinomial factors into that. Over. Now the bottom, well, that's a 4 by 4. I can't do this quickly. I got to take my time. I got to go 2 by 2. So x squared, I shall take out from the first and get x minus 2. Plus x minus 2, nothing for me here to take out but a 1. And that's x minus 2. Plus x squared plus 1, can't do much. Over. What could I take out from x cubed plus x like this? An x? Sure, let's take out an x. X squared plus 1. Let's complete the factoring of the bottom here. So this is x minus 2, x plus 1, over. Common factor here, x minus 2, I can take it out. And I'm going to have x squared plus 1. All this plus that. Now let's see if we can simplify this before doing the so-called addition. Now, there's many a thing that cancel out. Namely this and that. Lovely. And here, this and that. Wow. This and that? No, because they're not exactly the same. X to the 1, x to the 2, I cannot cancel those because they are followed by a plus sign. Only times and minus are good. So here we are with x plus 1 over x squared plus 1 plus 1 over x. Now we are actually ready to take a common denominator on this expression. Again, active principle number 3, how do I take a common denominator? A over b plus c over d. So we're going to multiply the denominators. Here's x squared plus 1 times x. And then what do we do with the numerator? We crisscross. So x plus 1 times x plus, what is 1 times x squared plus 1? Just x squared plus 1. Good. So to finish the problem, we shall FOIL the numerator, collect our like terms, and box our answer because we are practically done here. So what's this? X times 1 and x times x. That's going to give me x squared plus x squared plus 1. I'm not really going to bother foiling the denominator. I can just leave it like that. Nothing for me here to collect. So what's my final answer? Collecting like terms in here gives me 2x squared, right? X squared plus x squared is 2x squared plus x plus 1 all over x times x squared plus 1. And then again, there are no possibility of top-bottom simplifications because this x and this x, oh yeah, this x is free to move because it's multiplied, right? But this x is not free to move because it is added. Alors, this is my final answer. I will box this and basically consider my example 3 done. All right, so we went a little fast over the product sum of the trinomial here. Once again, if you are not really seeing what's happening here, Take your time, stop the video, and do it slowly on your own. All right, one more. One more example. What shall we have here? What do we have here that I prepared for you? Oh yes, I have example 4, and I think we will complete this video with our last example, 3.5 stars. Simplify completely. The following expression, this is x over x minus 1 minus a over a minus 1, all of that jazz over x minus a. All right. So what do you think we should be doing on this guy? I have a numerator that is a fraction minus a fraction. So why don't we focus our attention on the numerator for now, and then we'll deal with the x minus a downstairs later. Okay, so the top numerator. What is my numerator? It's x over x minus 1 minus a over a minus 1. Again, two fractions that are being subtracted calls again for a common denominator. So a common denominator is obtained by multiplying the two denominators together. X minus 1 times a minus 1, and then we crisscross. X times a minus 1 minus a times x minus 1. So x times a minus 1 minus a times x minus 1. They look alike a lot, so we got to be careful the way we do this. We don't want to get them confused. All right, here's a little foil. Here's a little foil in the hope of being able to collect some like terms. So ax, of course it's x times a, but we prefer to put them in alphabetical order, minus x. This is going to be ax with a minus, and this is going to be minus a times minus 1, so plus a. All over x minus 1, a minus 1. Good. Some simplifications in the numerator include this and that. Yes? So what I have is minus x plus a over x minus 1 and a minus 1. This is what is in this red box here. It is the numerator and the numerator only. Of course, I still have to divide this entire red box, this entire denominator. I still have to divide this by x minus a. So now, let us give ourselves a little bit of room. So let's get rid of this. And let's continue this problem. So let me rewrite what we had. X over x minus 1 minus a over a minus 1 all over x minus a. I'm rewriting the problem here. Equals to what? Well, the numerator, we have achieved this. We have achieved minus x plus a over x minus 1, a minus 1. That happens to be divided by x minus a, right? This means divide. So that means divided by x minus a. Would you concur? Right? Changing the notation a little bit here. So this division bar simply means divide by x minus a. Did I copy this right? Didn't make any recopying mistake here. Looks about right. Okay, what shall we do with this? What about minus x plus a over x minus 1, a minus 1, no change here, divide. What happens if I change division to a multiplication? You know that. We flip that fraction, right? It becomes 1 over x minus a. And now I actually wonder, are there any top-bottom simplifications? Well, once again, these two look alike a lot, but they're not the same. The sign in front of the x here is minus, while the sign in front of the x here is plus. The sign in front of the a is plus, while the sign in front of the a is minus. So they look the same, but exactly opposite in signs. We've seen what we can be done with this before. So what do you say? What do you say? Factoring out from minus x plus a, factoring out a what? Minus 1. Yes. Pull out a minus from minus x plus a. So pulling out a minus from minus x, I get x. Pulling out a minus from plus a, I get minus a. Oh, that looks quite good. So a minus 1 times this guy, 1 over x minus a. And now I have a top-bottom simplification, don't I? I have this and this, which gives me my final answer, which is going to look like this, minus 1 over this denominator, x minus 1, a minus 1. And it's pretty much the most that can be done with this. So once again, why are we doing all this? Because in calculus, an expression like this will turn out to be problematic. But if we are able to transform it into something like this, then the problem that arose from this format has disappeared in that format. It's like magic a little bit, right? It's like we transform things, and when there was a problem, in the end, the problem is gone. So these are the skills we'll be practicing on our next assignment. And that's it for today. I wish you well, and I'll see you soon. You take care now.